Hey guys, okay, we're going to find the limit, right? So we are given three terms right here. And what we're going to do is we're going to try to find the limit as t approaches 0. So what you can do is whatever number they give you, it happens to be a 0, we're going to throw that in every single place there's a letter t, right? Letter t. So, and we're going to do all three of them separate. So every single one of these terms we're going to do separate. They're going to get their own little limit arrow thing right here. Cool, so let's try the first one, which is e, -3, and t. So all I'm doing is rewriting it, except everywhere there's a t, I'm placing a 0 in there. So up here, -3 times 0, what does that give me? It actually gives me a 0, right? And anything risen to the power of 0, it doesn't matter what is hanging out with it. It doesn't have to be e, it could be anything. It's going to be 1. It's going to be a 1. So a good way to remember that is, so back when I was in high school, there was a math club, which I was certainly not a part of, but there was a math club, and they made these t-shirts, and in the back of the shirts, it said, "We are number," and it was this huge, elaborate math problem. The entire back of the shirt was taken up by this very long-winded math problem, but the entire huge math problem had parentheses, like all this stuff written, and it had a little tiny 0 at the very top for the nth degree. Because anytime you raise anything, no matter how elaborate it is, to the power of 0, it becomes 1. So it was a math joke. The whole joke was, we are number 1, right? So I don't know if that helps you remember, but anytime you see anything risen to the power of 0, number 1. Let's try the next guy. So I have limit as t approaches 0, right? This time I have a little fraction guy going here. So let's go ahead and replace everything with 0. Okay, so what does that give me? It gives me a 0 up here, and sine with 0 is actually going to give me a 0 as well. So I can't have this. This is called indeterminate. So I spell it? Form. Indeterminate form. We cannot use this. This cannot be an answer. I can't just go, oh, it's 0. Inappropriate, not allowed. What do? I just find the derivative. I'm going to call it L'Hopital, right? So all I'm doing is finding the derivative. So when we're dealing with limits and we're using L'Hopital, we're going to find the derivative upstairs and downstairs. We're not going to do quotient rule. We're not going to do product rule. We're going to treat it as if it's a little house, like a 2-story house or an apartment complex. You're the maintenance man. You're going to take care of the maintenance request downstairs and the maintenance request upstairs, right? Because it's 2 different apartments. They have 2 different problems. So the derivative upstairs needs something different. The derivative downstairs needs something different. So let's go ahead and try. So let me get rid of that box right there. Okay, so we go ahead and have an equal sign with an LH on top for L'Hopital, and I'm finding the derivative. So I had this right here, right? This is what we originally had. So what do I do is I bring down the nth degree to the front, becomes a coefficient, and it becomes 2t. And then I'm going to bring the nth degree 2 to the front. I'm going to use chain rule. Sine, I'm going to keep what we have, and then I'm going to do the inside second, which is in fact cosine t. Positive cosine t, it's not a negative, right? So now I have 2t, 2 sine t times cosine t. Let's go ahead and put the zeros up in there because I already found the derivative upstairs and downstairs. 0, 2, sine 0, cosine 0. Well, I get a 0 upstairs. What about downstairs? The maintenance request downstairs. Well, I ended up with 2, 0, and 1. If you plug sine 0 into the calculator, you get a 0. If you plug in sine 0 into the calculator again, you get a 1. What does that give me? Well, it gives me 0 over 0. It's still indeterminate. Still indeterminate. Okay, what do I do now? Well, I'm going to do another round of L'Hopital. Let's move over to the next page. I'm doing another round of L'Hopital. Right? So what did we have earlier? We had 2, what did we have? We had 2t, then we had 2 sine t cosine t, and then it was 0 over 0. So we're going to do L'Hopital again. You might have to do this like 20 times. You know what I mean? So this was what we originally had, and then we ended up with this guy, but we can't even use him because we cannot do 0 over 0. So I'm just going to do L'Hopital one more time. So this is what we're using, and we're just going to find the derivative upstairs and downstairs again, right? You're going back, you're doing another maintenance request, right? So the t becomes a 1, and then I have, okay, it's going into product rule now. It's going into product rule now. So we're going to do 2 sine t becomes negative sine t, right? Plus, here's the formula that I'm using, right? So 2 sine t is f, cosine t is g, plus 2, let's do cosine t, cosine again. Okay, it's getting elaborate. Great. Let's see. Does that look right? Yeah, cosine, cosine. Okay, so now I have, let's clean it up. You don't even have to clean it up. I usually do. So I have 2 cosine t minus sine t squared. I took this and I moved it to the back because there's a negative right here. So I thought it'd be easier visually for us to see. Right? So let's go ahead and apply the limit again, right? We're going to throw that 0 in there. And I got 2. Then I have 2 again, cosine 0, minus sine 0. What do I end up with? I end up with a 2. This is parentheses, so it's 1 minus 0, right? So what does that give me? It gives me 2 over 2, because 1 minus 0 gives me 1. 1 times 2 gives me 2. And what is my answer? 2 divided by 2 is 1, right? So with the first problem, it was a 1. With the second term, it was also a 1. Let's do the third one. The third one is right here, which I have no room, so let's start over here. Just perfect. We got a brand new page. We're going to find the limit. Every time you do one of the terms or work on one of the terms, you got to put this up in the front. So you're going to do that 3 times minimum, right? So let's see. I have cosine 2t. We're just going to throw it in firstly. First, we're going to throw it in, and then we determine if we're going to do anything else. Cosine 2, 0. Well, what does that give me? It gives me cosine 0, because 2 times 0 is 0. What does that give me? Oh, wild. It gives me a 1 again. I don't have to find the derivative of this, right? So I don't have to use a negative sign or anything. So what does that give me? So we're going to write out the final answer because we already basically completed everything, right? Limit t, and we're going to rewrite the entire problem up front. Oops, I forgot the I. T sine j cosine 2t k equals, sorry, my cat hit me, equals 1, 1, 1, right? This isn't component, form, component form. You can also do it in the form where it's ijk, which would be 1. You could do or equals I plus 1 plus 1k. Another way to write this is just I, j, k, right? So all three of these are correct, all three of these, because they're just telling us it's 1, 1, and 1. Those are the limits. Okay, I hope this helped. I have a shop. You don't have to go look at it if you don't want to. Okay, bye, thanks.